This is the Mandelbrot set, one of the most beautiful and remarkable discoveries in the entire history of mathematics. Yet it was discovered as recently as 1980. The invention of the silicon chip in the 1970s created a revolution in computers and communication, and hence transformed our way of life. We are now seeing another revolution, which is going to change our view of the universe and give us a better understanding of its working. I'm Arthur C. Clarke. I write science fact and science fiction. You may know my movie 2001: A Space Odyssey. I've seen some remarkable developments and inventions in my lifetime, but one of the most extraordinary is the Mandelbrot set and fractal geometry. This film will explore the fractal universe, and on our voyage of discovery, we'll be helped by Professor Ian Stewart of the Mathematics Institute, University of Warwick, and author of over 100 published scientific works. Dr. Michael Barnsley, former professor of mathematics at Georgia Institute of Technology, who received a $2.5 million government grant in 1991 to develop fractal image compression systems. Professor Stephen Hawking, the mathematician and cosmologist, and author of the best-selling book, A Brief History of Time. And finally, Dr. Benoit Mandelbrot, whose unorthodox mathematics led to the discovery of the Mandelbrot set and fractal geometry.
I first saw the Mandelbrot set somewhere in the mid-80s. I remember it quite clearly. We were at a mathematical conference on something totally different, and everyone went along to this exhibition because it was mathematical pictures. And there were these amazing coloured pictures on the wall, and I'd really not seen anything like this before. It's not easy to describe the Mandelbrot set visually. It looks like a man, it looks like a cat, it looks like a cactus, it looks like a cockroach. It's got little bits and pieces that remind us of almost anything that you can see out in the real world, particularly living things. So it has a character that reminds us of a lot of things, and yet it itself is unique and new.
The Mandelbrot set is real, an absolute thing, no question whatsoever. Any mathematician or any computer scientist or student in a school can study it and find the same, describe the same thing. It's a common experience. And so such things that can be magnified forever and have infinite precision do exist, but they're not touchable.
It's a geometrical shape, an icon, if you wish, which somehow embodies as an example a very important aspect of how the world works. Somebody recently actually called this set the thumbprint of God.
Now we'll begin our serious exploration of the Mandelbrot set, a voyage which, in fact, could last forever and ever, much longer than the lifetime of the universe. I have here the full set, about 6 inches across. Now, if I blow this up, I'll increase the magnification now 13 times, and you see more and more detail is appearing. And the interesting thing is you see mini Mandelbrots, replicas, almost identical, yet perhaps subtly different, of the original set. And I can go on doing this. Here's a magnification of more than 3,000 times. So the original picture, about 6 inches across, is now half a mile across. And no matter how much we magnified it, a million times, a billion times, until the original set was bigger than the entire universe, we would still see new patterns, new images emerging, because the frontier of the M set is infinitely complex. And when I say infinitely, I really mean that. Most people, when they say infinitely, they mean only or rather big, but this is really infinity. What is so remarkable, in fact, astounding, about the Mandelbrot set is that although it's infinitely complex, it's based on incredibly simple principles, unlike almost everything in modern mathematics. In fact, anybody who can add and multiply can understand the principles on which it's based. You don't even have to subtract or divide, still less use logarithms or trigonometrical functions to comprehend how the Mandelbrot set is created. In fact, in principle, it could have been discovered any time in human history and not merely in 1980. But the problem is this: although it's only based on adding and multiplying, you have to carry out those operations millions, billions of times to create a complete set. And that's why it was not discovered until the era of modern computers. It was on the 1st of March, 1980, at IBM's Thomas J. Watson Research Center in upstate New York that Benoit Mandelbrot first glimpsed the M-set. The seeds of this discovery were, in fact, sown decades before the M-set was first seen. In Paris, in 1917, a mathematician called Gaston Julia published papers connected with so-called complex numbers. The results of his endeavors eventually became known as Julia sets, although Julia himself never saw a Julia set. He could only guess at them, and it wouldn't be until the advent of modern computers that Julia sets could be seen for the first time.
For me, the first step, or most difficult mathematical problem, was to program it and see how it looked like. We started programming Julia sets of all kinds. It was extraordinarily great fun. And in particular, at one point, we became interested in Julia set of the simplest possible transformation. Z goes to Z squared plus C. So Z times Z plus C. I made many pictures of it. First of all, the first one was very rough. But the very rough picture, that was not the answer. Each rough picture asked a question, so I made another picture, another picture, another picture. And then